home and have a very good day. This video will present to you about optical wireless communication design of frequency modulation by using OptiSystem software. I will discuss a little bit about this assignment, which use free space optic (FSO) to design the circuit. FSO is a new technology that utilizes a light beam propagation through the atmosphere. The signal transmission is from the transmitter to transfer data received on the other side of the two-point communication system. The FSO communication is also called optical wireless communication, fiberless, or laser communication. In this circuit, to complete this circuit, we analyze the frequency modulation, or called as FM, is a more sophisticated modulation scheme than AM modulation. FM also has the advantage of eliminating the need for highly linear optical components that are required for AM system. This combination of optical wireless indoor communication system provides a flexible approach for local area network, mainly in large buildings or in a group of several buildings. The signal propagation, mainly in line of sight, is really on an uninterrupted line of sight path between the transmitter and the receiver. For this assignment, there is a few objectives that we need to achieve. First, to familiarize with the usage of OptiSystem software. Second, to design an indoor optical wireless communication link based on parameters given using frequency modulation techniques. And thirdly is to understand the operation of OptiWave performance software. Next is electrical circuit with FM modulator. This circuit works same like electrical circuit without modulator, but at the transmitter part there is a little bit change, which is for electrical circuit there is electrical frequency modulator after RZ pulse generator, and then there is a change of optical power meter with optical spectrum analyzer. Next is electrical circuit with FM modulator. This circuit works same like electrical circuit without modulator, but at the transmitter part there is a little bit change, which is for electrical circuit there is electrical frequency modulator after RZ pulse generator, and then there is a change of optical power meter with optical spectrum analyzer. For the last circuit is assigned as optical circuit, which is actually this circuit also work same as the other two circuit, but for this circuit MZ modulator is removed and being substituted with optical frequency modulator. This optical frequency modulator have three ports. For the left side, it is connect to direct to CW laser. For middle port, it is connect to RZ pulse generator, and the other port it is connect direct to channel part. This FM modulator function as encoding of information in a carrier wave by varying the instantaneous frequency of the wave. Next is analysis part of the result. For the first circuit modulator with electrical without modulator, the analysis is done by changing the FSO channel attenuation and observe the BR analysis at the different range. The frequency that has used is 1550 nanometer with power 100 meter watt. For the earlier stage, value of attenuation of FSO channel has been set with value of 15 dB per kilometer. The output that can be seen at BER analyzer, I diagram and Q factor by changing range from 0 to 5 meter. When range at 1 meter, maximum Q factor value is 4835.29. minimum BER is 0 and eye height is 1.21366 compared with range at 5 meter. Maximum Q factor value is 2124.22. Minimum BER is 0 and eye height is 0.898413. Minimum BER has a static condition with value of 0 even the range is changed. From this analysis, it can be observed when range is increased, the value of maximum Q factor and eye height will be decreased. In other point, when attenuation is up to 500 dB per kilometer, condition at range 1 meter shown the maximum Q factor is 5729.77, minimum BER still 0 value, and eye height is 1.084947. Compared to 5 meter range, the maximum Q factor is 2104.39, minimum BER still 0 value, and eye height is 0.514098. The attenuation value play big role that can change result value. Compared to previous attenuation, with attenuation at 500 dB per kilometer, when Q factor at range 1 meter increase but decrease when range changed to 5 meter. The value of eye height has similar condition as before, which is decrease. Change of high attenuation make maximum Q factor increase and eye height decrease. Perform the perfect shape of BER. Race cars and spaceships and carnival rides. Now the analysis of electrical circuit with FM modulator. This circuit is set with frequency of 718 nanometer and power of 100 milliwatt. The output analysis of electrical with FM modulator added which the frequency value is set to 250 Hz with the same setting as FSO channel in electrical circuit without modulator. The value of the parameter is unstable when the range change from 0 to 5 meter with 15 dB per kilometer attenuation, which is it show the best output is at range 5 meter. When the attenuation is varies up to 500 dB per kilometer, the good Q factor output can get in range of 3 meter, where the maximum Q factor value is 240 and 240.169 compared to the other range, which is the value more lower. This is because by theoretically, the higher the Q factor value, the best suite for the optical wireless communication system. For the optical circuit with modulator, the wavelength of 780 nanometer and power of 100 milliwatt and 25 terahertz of frequency deviation is set. By using the earlier value of attenuation with 10 dB per kilometer, the analysis of the BER analyzer show the Q factor value of 79.145, minimum BER value of 0 and 0.918894 value of eye height at the range of 4 meter. When the attenuation value is changed to 25 dB per kilometer, the value of the BER analyzer is decreased to 67.6834 for Q factor and 0.834713 for eye sight value. The eye diagram revealed that If we increase the attenuation value with the same system configuration, the result become low performance because the BR analyzed value of Q factor keep decrease. So that's all the analysis result that we can make from this 3-circuit output. As for the discussion of this assignment, the optical wireless communication is a form of optical communication which unguided visible, infrared or ultraviolet light used to carry a signal. It operating in the visible band that refer to visible light communication which the system take advantage of light emitting diodes which can be pulsed at very high speed without noticeable effect on the lighting output and human eye. It also can be divided into 5 categories based on the transmission range, which is ultra short range, medium range, long range and ultra long range. It are very simple to implement and bandwidth efficient like the on-off keying or OOK, pulse interval modulation PIM technique and pulse position modulation PPM technique. From this assignment of optical wireless communication design with OptiWave system, the optimum receiver for an OOK signaling is the match filter followed by a threshold detector set at midway between the 0 bit and 1 bit energized. For OOK to perform optimally in a multipath channel, the maximum likelihood sequence detector should be adopted. The modulation techniques have been described with reference to power efficiency, bandwidth efficiency, and error performance. The selection of a particular modulation technique depends on the intended application and the channel configuration of interest. As for the conclusion, this objective of this assignment is successfully achieved because we able to use OptiSystem software as the main element for this assignment, and we able to familiarize with this OptiSystem software to develop this design which will be easy to handle if we understand the software. And the indoor optical wireless communication has been designed based on the parameter by using the frequency modulation techniques. By doing this assignment, we looking forward for the future trends that may be able to be done in the future, where we suggest for the evaluation of 5G technology, offering possible a cellular optical wireless option. New version of standards in such cases would emerge, and evaluation of this would be development of zero delay links. Such would be important in very fast connection where large crowds involved using low cost short range links and device able to transmit and receive data simultaneously. That's all from us. Thank you for watching, and don't forget to subscribe to our channel. When hope begins to fade, a lonely road crossed another cold state line, miles away from